G'day everyone, Gareth Ford here with the next instalment of the Regional and Remote Communities Reliability Fund video briefing covering renewable microgrid hubs for regional areas with an emphasis on ammonia and associated products. This is a project completed by All Energy Proprietary Limited in collaboration with Ballon Shire Council, funded by the Australian Government. Let's have a look at ammonia and fertiliser markets. Australia, around about $1 billion per annum in ammonia. 20% of this is exported. Globally, there's over $28 billion per annum US traded in ammonia. But then when you look at fertiliser, there's almost $4 billion per annum of fertiliser used in Australia, with 95% of this imported. And this provides a real supply chain risk. Ammonia, also called anhydrous ammonia, which means without water, has one of the highest nitrogen concentrations of any fertiliser. Why are we hearing a lot about ammonia at the moment? Well, you can generate renewable ammonia from renewable hydrogen, and then that has quite a dense hydrogen concentration on a tonnage and a cubic metre basis. But in particular, up until just a couple of years ago, ammonia was reasonably stable in price at about $300 US per tonne. With recent natural gas spikes, that resulted in a spike in ammonia cost of production as well. The cost of production's come off the boil. It's a bit below $1,000 US per tonne, but when you convert that into metric tonnes to Australian dollars, you're at about $1,416 free on board FOB. Plus there's an impost of $300 per tonne for transport, that's shipping and then trucking to the point of use, meaning that the current cost of ammonia is at about $1,706 per tonne. So this provides an opportunity for renewable ammonia to be made from renewable hydrogen. Let's take a look at that now. Ammonia has also been called the Swiss Army knife of renewables. So let's start with renewable energy. So within a Queensland, Northern Australian environment, this would predominantly be solar, with the opportunity for energy from waste and biomass to provide continuous power, and also wind energy and possibly some green grid power. That intermittent power is quite well suited for producing hydrogen from an electrolyser. The hydrogen is one of the main feedstocks that goes into a Haber-Bosch reactor to produce ammonia. Once that Haber-Bosch reactor is turned on, you really don't want to turn it off. So about 5% of the overall power need for the whole facility would be continuous power for ammonia. And then you can have intermittent power, so such as solar, producing hydrogen, which can be compressed and stored for later use. The other main feedstock is nitrogen, which can be obtained from an air separation unit. Brackish or saline water can be processed through a reverse osmosis system to make water of a suitable quality. Water is definitely required, but there is quite a lot of hydrogen in water, so the amount of water required is quite modest overall. The key product of interest today is fertiliser. So for broadacre cropping, wheat, cotton, horticultural uses, but they can also be converted into a solid urea prill. There's also a lot of interest in the use of ammonia as a transport fuel for industrial uses, such as converting into ammonium nitrate for mining and explosives, and export into global markets. Let's have a look at an example where a high voltage transmission line, the cost for that is compared to the cost of a renewables hub. So about $3 billion of funding for a 500 kilometre HV power line. For that same outlay, you could have a plant producing about 500,000 tonnes per annum of ammonia. This would equate to about 14% of Australia's total fertiliser requirements. However, you could split this into 10 hubs, each producing about 50,000 tonne per annum ammonia or urea or other derivatives such as ammonium nitrate. This would mean that jobs can be created in specific regional areas and green products for agribusiness and mining, and also avoids land access requirements associated with those transmission lines. We've got here a fly through of a ammonia facility maintenance in this area. This is the main Haber-Bosch and ammonia reactor area, the electrolyzers, water tanks, compression, hydrogen storage, and hydrogen loadout system. Liquid ammonia can be trucked at 17 bar gauge, which means it's in a liquid form and has a reasonably high density. Thank you very much for listening to the presentation today. As mentioned, this was a Microgrids project in collaboration with Boulogne Shire Council, and feel free to email myself or my colleague Max if you have any questions. Goodbye.